Hello, everyone, and welcome to the 2024 William Hooke Lecture in Science and Society. Before we get started, there are a few people that made today happen or are making today happen who I want to thank. I want to thank my colleagues Isabella Herrera and Emma Tipton, Neil Jacobs, Keith Sider, Christine Carr. All of them were hugely helpful in making this possible. I want to thank all of you for joining us today, taking time out of busy schedules to be with us. It's great to see all of you, and I look forward to talking with you later. I also want to thank the person who made all of this possible, Bill Hooke. We're very fortunate to have Bill with us today. Thank you, Bill. Thank you, Bill, for the career that justified creating the Bill Lecture. And thanks to our speaker, we are in for a treat. I saw Karen St. Germain give a lecture to the AMS Summer Community Meeting several years ago, and it was terrific. As a result of how good that lecture was last year, when I was trying to think of who to invite to give the colloquium keynote address, I turned to Karen, and she did a fantastic job with that keynote address. We really enjoyed it. And so this year, as I thought of who to invite to give the Hooke lecture, I thought, we'll go to Karen. And it proves one of the collective wisdoms of Bill Hooke. Those who've been here before know I want to share one of Bill's wisdoms each year. And this one, Karen proves, only succeed at those tasks that you wish to be asked to do again. Well, Dr. Karen St. Germain is the director of the Earth Science Division of NASA's Science Mission Directorate. Please join me in welcoming Karen St. Germain.
Oh, Albany?
Albany.
We can come back to that. Hi, everyone. It's really an enormous honor for me to be here with you today. Thank you for taking time out of your day. I know you had choices, so I really appreciate that you're here. I will do my best to make it worth your time. One of the reasons it's an honor to be here is because this is the Bill Hooke colloquium. Bill back in the back left corner there, and I didn't know he was going to be here. So we'll see how this goes, Bill. I'm going to tell a story. I hope tell a story that ties to some of the work you did more than a decade ago, and looks to the future. Bill's a gift to humanity, and because of his deep thinking, but because of the way he communicates, and I think this colloquium, this series is also a gift to humanity because of what it seeks to do, to tie science to the decisions we make as a society, large and small. And so I'm going to just give you some thoughts on that. The science can and should inform what we do. And policy, in many ways, drives how we do it, and certainly how fast we do it. So there's sort of a natural synergy here. Actually, I was going to ask how many people in the audience have read Living on the Real World, those books that he wrote more than a decade ago, but then it could be embarrassing, right? You might not want to raise your hand or not raise your hand in front of us, so I won't ask. But I'm going to make references to the book. If you haven't yet had an opportunity to read it, I would recommend that you do. And in that, in Bill's book, he talked about the climate crisis as a wicked problem, and of course, there are real attributes of the challenges in front of us that deserve that title. So, of course, human activity is introducing changes to the way the Earth system works. And those changes are creating some pretty urgent challenges. There are increasing and distributed climate-driven hazards. These are, natural events that are severe in nature. But what's also happening is an increase in our vulnerability to those hazards, to those extreme events. Just as an example, we just recently passed 8 billion people living on this planet, and about 1 billion of those people live in low-lying coastal regions. If you've been tracking sea level rise, you can do the math and understand the increasing vulnerability to just one of those climate-driven hazards, the risk of flooding events. And of course, hazard plus vulnerability equals potential for disaster. So, there are those kinds of challenges. There are also what I'd call long game challenges, threats to our infrastructure. We have built most of our infrastructure, including, let's just say the infrastructure upon which our economies sit. Most of that has been built up over the last century or so during a period of pretty stable climate. And now as we're moving out of that period, we have a lot of vulnerability that we're not even used to thinking about. We're used to thinking about things like hurricanes, but we're not used to thinking about the kinds of changes that are ahead. So, so those are a few of the attributes. Another thing that makes this hard to project is because the Earth system is a pretty complex system, and humans are in the loop. When we talk about projecting climate change, we know where there are uncertainties in our models about how the Earth works. Things like the relationship between aerosols in the atmosphere and the clouds that get seeded by those aerosols, and then how reflective are those clouds. Those kinds of things, we know that those are sources of uncertainty. But the biggest source of uncertainty is, what are the humans going to do? Right? So with humans in the loop and a complex Earth system, we've got a pretty wicked problem. And the stakes are pretty high. One of the things, how many folks in the room are familiar with the World Economic Forum Global Risk Report? Anybody? About half of you. So this is a report that I read. I take a look at it every year, and I have been doing so for more than the last decade. The World Economic Forum is an international NGO. It's a think tank kind of place. They're located in Geneva. And it was started by a German engineer by the name of Klaus Schwab in 1971, I think, or thereabouts. And I'm going to just read a little phrase here. Schwab saw the need to connect leaders from politics, business, academia, and other sectors of society around the globe for the purpose of establishing trust and building cooperation for humanity's progress. So to be clear, this is not a science organization. This is an organization that's populated by leaders in different economic sectors, leaders in policy, technology, from all around the world. And the Global Risk Report, the annual Global Risk Report, is one of the keystone initiatives of that organization. It's changed a little bit over the years, but at present, what they do is they assess risks to global well-being. And they do that on timescales from present day to 2 years out to 10 years out. And when I say they're looking at global risks, I mean the kinds of categories are economic risks, environmental risks, geopolitical, societal, technological. So for example, when they talk risks, they're talking weapons of mass destruction, global pandemics, all the full range of the risks to well-being for humans around planet. In the most recent report, the 2024 report, in the key findings section, it's right out there at the beginning of the report. It says, and I'm going to quote here, environmental risks continue to dominate the risk landscape over all three timeframes. Nearly all the environmental risks that they track feature among the top 10 over the longer term. The top 4 risks in the 10-year horizon in this year's report are in order: extreme weather events, critical change to Earth systems, biodiversity loss and ecosystem collapse. It's number 3, and number 4, natural resource shortages. To it, and that includes water as part of that. So the top 4 risks to global well-being are right in the sphere of understanding how the Earth is changing, adapting to what's happening, trying to mitigate future change, and make better decisions, right? So, and I'll just give you, the idea that extreme weather events was right at the top caught my eye, so I just looked up the numbers from last year. External to the US, the cost of billion-dollar extreme weather events, so we're not counting all of them, just those events that on an individual basis cause $1 billion or more equivalent in damage. And adding those up around the world, the number is $149 billion in fiscal year 23, calendar year 23 alone, outside of the US, and 8,030 lives lost attributed to extreme weather. And in case you're thinking, well, that doesn't happen in countries like ours, the numbers in the US last year alone, same metric, $1 billion weather related events, 88 billion and 382 lives lost. So this is pretty real. And it underscores something that, that Bill actually pointed out in his book, that our relationship with Earth. I'm sorry, I give a lot of talks to NASA audiences, and I'm used to referring to this as our home planet. Is that why? Anyway, our relationship with Earth is a complex one, right? It's a resource. It provides the air, the food, the water, everything we need to live more than 20 seconds or so. It's also a threat, right? We are also, as humans, vulnerable to environmental threats through natural hazards and climate change. So, and then to make it more complex than that, we humans have conflicting interests, right? So it's a pretty complex relationship, a wicked problem. One of my favorite things in living in the real world was the question that Bill asked: what kind of world do we want to live in? And I'm going to guess that that's a question that drove you all to sign up for this colloquium, right? This idea that I want to think about and then bring into reality my vision of how the world should be. What kind of world do I want to live in? So, as Paul mentioned, I am responsible for Earth science at NASA, the best job on Earth. And we took our swing at answering that question. In the document that we passed around, or at least a flyer for the document, our answer was we want to live in a thriving world that is driven by trusted, actionable science. So that was our starting point. And you have to have a starting point to figure out what you're going to do. You got to know where you want to go. So that was our answer. And to sort of add more meat to that skeleton and talk about, well, what do I mean by a thriving world with driven by trusted action and science? That means I want to live in a world where we can anticipate the changes that are coming. We can adapt our decisions, and those could be policy decisions, and they could be really tactical decisions. But we want to be able to adapt to the changes we see coming. We want to anticipate the side effects of those choices that we're making. We want to build resilience to the extremes of nature. We want to think ahead about shaping the environment we want to live in. And we want to enable people to make, this might be the most important one, to make informed decisions where and when they need to make them. So that's what's sort of behind the vision, and you're gonna hear me keep referring back to Bill's book, because I think the ideas in there are even more relevant now than they were when he wrote the book, which is a pretty great accomplishment, I'll say. So we'll talk about 4 tools: policy to enable quick and effective action, a basis of fact to inform your decisions, the IT and social networking, in other words, the ability to learn from one another quickly to increase the pace of learning, innovation, and sharing of results. And then the 4th was distributed leadership that enables communities around the world to achieve their aspirations, to make decisions that support their vision for their future. And so at NASA, we are doubling down on these tools. 3 of them, so NASA's not a policy-making organization, but we believe that our science should be policy relevant. And we think the other 3 tools are incredibly important for us to lean into for the purpose of making sure that what we do is policy relevant. So our approach, and the reason I handed out that little flyer, because I didn't want to have slides. So you have the little aid, but on the back side, you see a pyramid. That is the quick visual encapsulation of the strategy, and I'll just sort of walk you through what we're talking about. At the base of the pyramid, and it's the base because the foundation of everything we do, is our observations, our data, our technology, the ability to invent the thing that we have to invent to make the measurement we need to make, to answer the question we have to answer, to increase our knowledge of how the system works. That's all, those observations, the measurements, the technology, the data, those are the base of the pyramid, and that's been NASA's core business for a lot of years. And our business in partnership with our sister agencies like NOAA and the US Geological Survey. Building on that, though, once you have the observations and that reservoir to draw from, then you can start learning through discovery and applied science. That's really where we're turning data into information and understanding. And then as you move up the pyramid, from there we can develop solutions and societal value. That is, take that understanding and begin putting it in forms that people can really use. Top of the pyramid is that really trying to advance public understanding and exchange of information. And then you see a virtuous cycle, and that's really important. I cannot emphasize enough the importance of building learning into our whole system, not just our science system, although that's super important, but the whole system of gaining new understanding, putting it into use, figuring out where we thought we understood something and maybe we didn't have it quite right, using that to feedback into the questions we ask, the systems we build in the future, and all of that. So that's sort of in broad brushstrokes how the strategy frames up. The whole idea is we have got to accelerate the pace of discovery because the Earth is changing faster than our traditional science processes get us new understanding. So we have to up our game, which is not a criticism of the 2 to 3 decades behind us. People did great work and laid the foundation. But now that we have that, we have got to accelerate the pace of learning, the pace of understanding, and we have to accelerate the uptake of that understanding into society. So that's how we structured this pyramid with a lot of little feedback loops in between all the layers, including the big one that goes from the top to the bottom. We're also all in on working with partners to advance this vision. Because we know what we know, but, you know, people trust who they trust. We don't have time to start from scratch, building new trusted relationships. So we have to work with the organizations, the agencies, the NGOs, the university extension programs, the international organizations. We have to work with the people who already are the trusted partners for people around the world. That's the way we get to scale the impact here. We also, so people trust who they trust. The other thing is people know what they know. We don't have time for us, my team, to try to learn everything about agriculture, everything about managing air quality. That's not the point. The point is for us to translate what we understand into a product that, or a partnership that people who know those businesses can use and can use to advance their decision making. So again, going back 12 years to living on the real world, Bill wrote about the fact that we're compiling data and scientific analysis to a point that it is out of reach in most decision makers. And he went on to make the point that it is incumbent on the science community to make that science available to people, to decision makers in every sphere of life. Well, since he wrote those words, there have been tectonic shifts in capabilities. One example, affordable data storage and compute in the cloud was not available then. Machine learning and really fast advanced analytic techniques, all or many developed since then. No. Global connectivity through the roof in the last 10 years. All of this, by way of saying, these things have fundamentally changed how we can go about connecting science to society. And we've got to use them to democratize science, to mainstream science. And in a lot of cases, we're seeing science getting commoditized, which is interesting. It's yet another way to get science out into the hands of people who need it. I think we should recognize, you know, I spent the first half of the first chunk of this talk talking about the risks, the challenge of this moment that we're in. But we should take a moment to recognize the opportunity of the moment we're in. I started talking about the World Economic Forum. Well, they issued a different report, an additional separate report, just in the last year. And here are feedbacks from this report. By 2030, the value of the global economy of Earth observation insights and science will likely surpass $700 billion. And when you hear that number, 700 billion, you might think, oh, well, you know, all this Earth observation and space stuff is expensive. The vast majority of that value is from making Earth science actionable to decision makers. So they talk about decision makers who farm, who generate and transmit electricity, the insurance industry and the reinsurance industry and the financial services industries, supply chain and transport industries, emergency response, public services, and on and on. The world is changing, and for the better. The world is positioning itself in all of these different ways to uptake this information to inform decisions from long-term strategic policy all the way to tactical decisions. In other words, when we make science usable, people actually use it. Some of you in the audience will have heard me tell this story before. You know, I grew up in Massachusetts, and we did not have much money. But what we did have was a little piece of land on the lake and an old camp. And so I spent summers, you know, romping around the woods and out on boats. And as soon as you're, you know, old enough, or your dad or your mom teaches you to drive a boat when you live on, you know, we have time on a lake in Massachusetts, so I was learning to drive a boat. The hardest thing about driving a boat is not driving a boat, it's docking the boat without hitting the dock when you're coming in, right? And so when I was learning to dock a boat, the thing that I always wanted was to have someone on the boat and someone on the dock. So all I had to do was get it close enough, and the guy, usually my brother on the dock, or my dad would reach out, and I'd have somebody in the boat with me, and they would reach out, and they would, person on the dock, would in the boat with lock arms, and pull the boat in. And that's sort of the visual I have here, is between the science community and the policy community, we have to work together, reach out, lock arms, and make it work. It's not about the science community perfectly delivering. And it's not about the policy community standing by and saying, gonna wait till the science community delivers. We've got to work together and make those connections. We need to ask the right questions across those boundaries, do the kinds of things that you all are doing in living in that boundary zone and making those connections. And I'm coming to the end game here. I'm hoping we'll have time for some conversation, but I want to end with some comments about optimism. Because we don't have a lot of optimism around us today for a number of reasons. I get really nervous when I speak with young people who seem to already feel defeated. And so it's incumbent upon all of us to actively nurture optimism in our communities, because people don't take action from a position of despair. They only act when they have hope. And so, and I recognize that optimism can be a challenge. How can we be optimistic when we have evidence of some really challenging circumstances? Well, on one level, people can say, well, we just have to. We must be optimistic. I actually believe that. But let's go a little deeper. There is an enormous difference between the best possible outcomes ahead of us and the worst outcomes ahead of us. There's a big difference. And in particular, I'm talking about climate here. It was millions of decisions, independent decisions, that got us where we are today, and it's going to take millions of different decisions to get us to those better outcomes. All right, that's a lot of work, but a society that understands is a society that can make better decisions, and we've done it before. We have examples in our history where we've done it. A society that learns is a society that can adjust and will make better decisions tomorrow. And I'm optimistic because I think the technologies and the will are in place to help us make this happen. We have measurements and scientific understanding. We have the means to accelerate the uptake of science. We're actively building those partnerships. The private sector is investing at rates that we could not have imagined a decade ago. We have computational muscle and the tools to deliver timely and accurate information that empowers underserved communities to reach their aspirations. I was at an event last night, and in some ways it was the ultimate bureaucratic event. It was leaders from operational meteorological agencies from around the world. They're meeting in DC today. It's a CGMS meeting, and they are grinding their way through operational challenges and figuring out ways to help one another out. And my old boss, Steve Bowles, said something that I thought was really inspirational. He said, part of our job is to be champions of hope. And I think that's true. So the call to action is urgent. This is the moment. And to quote Bill, to succeed requires knowledge and understanding, but that's only the beginning. It also requires courage and nobility, honor and humility, as well as decisions and action. And you and I, we don't get to opt out. So let's do this. Thank you. Prior to that isn't the full strategy, that there is a whole strategy, if you're interested in reading about it and giving us feedback on it. Little secret, when we had the first, draft that I was not embarrassed by, the first sort of one, Bill was one of the folks I bootlegged talking to and said, what do you think? And, he provided valuable, feedback. So, you can just Google Earthside's action strategy and get right to the website if you want to download it. And with that, I think, do you have time for questions and discussion?
Yes, we have time for questions, but we do not have mics for the audience. So I think we'll be able to deal with that okay. You're just gonna have to ask your question with a little bit.
Gusto.
Yeah, exactly,
Ask a
exactly.
question, Gusto. Yeah.
Hi, I'm a Kaunchal, a grad student at Maryland. You talked about private companies investing more heavily now. Do you think it's possible to save the environment and to do better policy in a for-profit private company who might divest the moment it's not profitable to their in their bottom line? So what I'm saying is, we have to take care of like the triple bottom line, which is profit for money, profit for society, and profit for environment.
Yeah.
So yeah, comments on that.
Sure, it's a great question, and there,
Can you
oh, yeah.
paraphrase, repeat for?
So the heart of the question was really about, for-profit companies, and whose business models may change and their motivations may change. How do we rely on them as partners in, solving, the challenges we have ahead? And it's a great question, and I think that could be the topic of a whole discussion itself. But what I'll say is this, look, first and foremost, full disclosure, I'm a public servant. I believe in the global good, right? I really do. And I don't think there's ever going to be a time when we don't really need, public services. I also think there's so much work to do that there's plenty of room for the private sector, whether they're for-profit, not-for-profit, nonprofit, to roll up their sleeves and help us solve the problems as well. So, so there are elements that I would not, that I don't think, should be, that I think the government should stay in the business of providing the global good, the public good, but I think there's plenty of room for lots of contributions, because the challenges are that big.
I'm Joey, I'm a graduate student at the University of Washington, and I'm curious, and you mentioned being like optimistic and, reaching out and collaborating with a lot of different groups of people. How do you avoid complacency as well as lock-in in certain procedures, like especially in your pyramid up approach, like you build technology and then you rely on this technology to, deliver information and then give that to people. And so how do we make sure we're incorporating all of the best ideas into this kind of process?
Oh, well, all right. There's a lot to unpack there. The question was really about, how do you not, let me know if I got this right, how do you not, just sort of fall into routine processes and become complacent? Or maybe another way to say it is, how do you keep innovation, and enthusiasm and acceleration as part of that approach? It's a great question. And I'm lucky, right? Because I work for NASA, where innovation is part of the DNA. So maybe what I should do is try to answer that from a broader perspective. And actually, I mean, others in the room may have really interesting thoughts on this. But to me, the world is an exciting place. And there's so much to do, there's so much to try. Building learning into the processes is sort of at the heart of this. And that's especially important in a research and learning agency like NASA, right? To build in the expectation of learning and advancement, to keep pace with the demand. But we get calls every day, with requests for new insights, support for, different applications of our science. So there's no shortage in my world of demand signal. And I think, you know, as long as there's demand, that's exciting. That injects energy into my world. People want what we can do. There's nothing more exciting than that. For me, anyway. Sure.
Hi, Renella Sprith, I'm from NOAA in the research line office. So my question is really related. You want to get to actionable science, but you want to accelerate the pace of learning. What's the appropriate, level of research that should be, you're going to have success versus this is risky, but it could be transformational? Because if you're only trying things that are conservative, you might not learn from your mistakes.
Yeah, this is a great question, and we grapple with this every day. And of course, different agencies will have very different answers to that question. I worked, some of you may know, I worked for NOAA for, I don't know, probably a total of about 11 years in 2 different chunks, right? So I'm most familiar with NOAA and NASA, but you find different versions of this answer if you work for USGS and others. So when you work for an agency that has, primary mission essential functions like watches and warnings and forecasts that have to be out, they have to be timely, they have to be right, that drives a certain amount of conservatism into the processes, right? Because there's very little tolerance for breakage. At NASA, we can and we do build portfolios of risk that have just much higher risk tolerance in them, because if NASA can't take the risks, then who can, right? So we, really try to inhabit that space. Now, we also provide a lot of data that agencies and organizations rely on. So we too are walking that line, but we intentionally build part of our portfolio to go for it. Right, and we have things that we actually call high risk, high reward. Let's see what happens. And I think you have to build some of that in. That becomes another part of injecting energy into the system. Those transformational technologies. And when I say technologies, I'm not just talking about sensors and things. It can be information technologies, new techniques, that sort of thing. I think you had a question, I think. Oh, you go. Okay.
Hi, Tamara Battle, I'm also with NOAA. This is not in any way meant to be negative, but 3 words that are rattling around in my head when you talk about coming together in partnerships in society are trust, equity, and credit. So there's a trust issue that's happening right now in our society, mistrust of science from the community, different agencies and organizations maybe not trusting each other. So I would love to hear you maybe address that. Also, equity in terms of resources. There are major players in the science community, but what about developing countries or areas, and how do we do enough to make sure that they are also welcomed into this as we're looking at technology, innovation, and so on and so forth. And then the third one is oftentimes when you have players, everybody wants credit. They want to be like, this is my swim lane, I own this, but it's going to really take a global approach to many of these topics. So how do you get past that where everyone wants to be the person in charge or the organization in charge or wants credit? That was a lot.
Yeah, but those are great questions, and they have to do with humans, right? We're humans in this endeavor. I won't be able to do justice to all the parts of the question, but I'll offer a few thoughts. Trust is a big one. And if there's something that keeps me up at night, it is that one. It's that trust is eroding a bit in our society. I think the way that we have tried to build it back, and I'll focus in this case particularly on people who might be interested in using our information, And it still does come down to relationships. It still does come down to, I need to understand what's keeping you up at night. And understand if there's something I can bring to that challenge to help. So taking a step away from dogmatic lines and really focusing on understanding one another, that requires, and I think this gets to your second point, it was
Equity.
equity. The often, well, and credit, often when people are worried about getting credit for their work, that really boils down to resource contention, right? I need credit because that's how I get the resources to do the next thing. So, when we talk about, work across agency lines, for example, we're working pretty hard, especially with NOAA, to go together. Say, here's what we do together, and to give you a sense of it, we have more than 100 active collaborative projects between NASA and NOAA today, right? So when we tell that story to our stakeholders, that can diffuse a lot of resource contention, and when the resource contention is diffused, we can worry a lot less about who gets credit. So, so again, relationships. And then with regard to equity, well, there's so much work to do there. There's so much work to do. But I'll mention, NASA's been in the business of applied science for quite a long time. And that means we've learned in many ways how to do it well. And we also have learned, how to do it poorly. I mean, we have cases where we moved into a user community, often in a country that doesn't have the resources we have, and we went in with a certain amount of hubris. We've got a thing, we've got a capability, it's gonna solve all your problems. A little humility goes a long way, right? People know what their problems are. I shouldn't presume I understand what they need. So we've moved to a model of a co-development, or really working with communities around the world. And we work with Department of State and USAID and the local or regional authority for whatever the issue is to figure out, do we have something that could be brought to bear to help them do their job, right? So it's a partnership, and it's relationships, it's humility, and it's actually listening that are the only ways I've found to try to get at the heart of some of those issues. Sorry, longish answer, but tough question. All right.
Hi, I'm Tatiana, I'm a PhD student at the University of Oklahoma. My question for you is, you talked about, we need to accelerate the pace of discovery along with the uptake in society. I'm just curious on what do you think, how do we accelerate discovery when I feel like from a young age, I've always been told sometimes science is slow and that it doesn't just happen overnight, especially since we've been learning about this week funding and how everything kind of comes back to, do you have the money for it? So how do you accelerate science if you don't have the money or the needs for it?
Yeah, it's a great question. And I want to point out, in part because Jack Payne is sitting right down front, and he'll bore a hole through my head with his eyes if I don't mention this. I want to really acknowledge, I say you have to accelerate discovery a lot. And I recognize that there is science that takes time for a number of reasons. Either because you have to see, sometimes it's because you have to see a trend over time, or because it's such a complex question. Whatever. So there are lots of reasons why science can take longer periods. But we had a lot of, I'll say, we have institutional practices that serve to exacerbate the problem. I'll mention a few of them. It has been the case that when we launch a new mission, that may be observing something about the Earth for the first time, that the science team that was chosen and funded has exclusive access to the data for too long, right? So part of this can simply be, even if I'm not sending more money out to the community, making the data and the science more visible while we're doing it. Right, so I didn't talk about it in my prepared remarks, but a big part of this strategy is what we call the open source science initiative. We stole the phrase open source, of course, from software development. But the idea is open source science is our answer to the idea of open science, which is to say, I want the data, the models, the code, the scientific exchange, all to be open, even to people that I'm not funding. More eyes on the data, more eyes on the science, more eyes on the information. That's more ideas, more intellectual energy coming into the enterprise. So that's one way to accelerate that process. The other way is to have potential users of data involved in our work from the very beginning. So another source of friction in the years is we would launch a new mission, then we fund the science, and then we develop some applications, and then we'd start knocking on the doors of users saying, hey, I got a cool thing. I think it's gonna solve your problem. And sometimes we got lucky, sometimes that worked, but the idea we have now is we want the user, the people who might use the information that we think we might get. We want them involved in the mission right up front, influencing even how we design it. We have an active early adopters program. So these are folks who are getting sample data or synthetic data way in advance, so that when the data hits, they're ready. So so we're trying to eliminate all those barriers between new observation and use as well. So a couple of ideas there. Mike.
Mike Fox, I'm with Maxar, I'm a 2013, I think it was, graduate of the co-field program. And one of the things I keep thinking about is economic expansion, not just with the defense of and the ability to maintain our current.
Yeah.
And when we bring these new observational assets online, have we thought about how that may enable some new part of the economy, right? Or enable a current part of the economy to grow and thereby help with the budget challenge.
Yeah, I mean, the most, it's a great question, and the most obvious example I can think of is food security and agriculture. That's a part of our economy, particularly important here in the US, but important around the world, that is challenged by changing climate, right? When I go out to Nebraska or Iowa and talk with farmers in their fields, which I do every year, they talk about how the rules that they learned to farm by don't work anymore. The rules they learned from usually their father, their grandfather, don't apply anymore because, the weather patterns and so forth are changing. So that's on the threat side, but on the opportunity side, well, we sure better figure out how to grow our food production and probably some more efficiency in that production, because we're at 8 billion people now, and there's no signs of slowing down really. So we're going to have to increase our agricultural productivity. And so we actually work really closely with the end users, with the agencies like Department of Agriculture and USGS that are partners in that domain, and look for ways to build what we need to build to enable future users to do things they can't answer questions they can't answer now, like detect disease in their crops much earlier, as an example, right, to reduce losses or increase growth. I'm not sure that's the best example, but it's the one that came to mind immediately. And I think it's a good question, and I'd love to hear more ideas on things that we could or should consider doing differently in that way.
Could take one more question if there is one.
No.
Hi, Neil Jacobs, UCAR and AMS. So we heard a lot this week from congressional staff, both majority and minority, about priorities and budgets, and they all said they were optimistic, but they all said it all depends on priorities and budgets. And I'm curious after, and I'm tying this back to Steve Bolz's quote about, champions of hope. What do you do personally, and what's your advice to early career scientists when the budgets and priorities don't necessarily align with what you would say is optimistic?
Oh, wow, thanks. It's a really great question, and if priorities don't align, the only way I know to close the gap is to find common ground. And so one of the things I do, and I'm, by the way, been on this job for 4 years now, but I'm still learning every day about how to do it a little better. And some days I learned spectacularly how not to do it. Yeah, in fact, I had an instance on the Hill just a few weeks back that was informative. I would go with that. But the idea is, when I talk to staff or members on the Hill, I first want to know, what do they care about? What are they worried about? And almost always, if I listen to what they're worried about, I can find a connection to the work that we do. And so for me, the key is to not come charging in the front door with, these are my priorities and why don't you agree? But it's really more about trying to find that common ground. And that, that comes back to also telling stories. You've heard me talk about this a lot, the importance of storytelling, because we're at the end of the day, we're talking about humans, right? And if you want to move hearts and minds, there are only two things move a person's heart or mind. The first thing is another person, right? A personal connection. The second thing is a story. And even the story probably has to be another person, right? So if, as you want to build your skill set for influencing the process, one way to do it is by really paying attention to the stories you tell and how you tell them. And that is another thing that I learned from Bill. And when you mentioned the first time you heard me give a talk, and Neil, you were there too, at that AMS banquet colloquium or banquet keynote. I had very little time to prepare for that. There was been a snafu in the scheduling, and I only got the request to give this keynote a few days in advance. And so I was pretty nervous about it. It was a diverse audience. There were people who are not scientists, people, that community forum brings people from across the enterprise. And this was a banquet thing, right? So there were going to be significant others there. It was very, very interesting. And so I was talking. I was really nervous about this, and I was trying to stuff additional facts in my head, and I was very busy trying to figure out how I was going to dazzle this audience. And so everybody else was at the reception having a glass of wine, and I was by myself at the table. And the gentleman in the back of the room walked up and he said, I'm alone at an 8-top table, and he said, is this seat open? And I said, yes, it is. And he said, my name's Bill Hooke. And I said, I know who you are. But he said, go ahead and sit down. And he said, so are you, you're giving the keynote, huh? And I said, yeah. And he said, are you ready? And I said, well, I'm trying to be. Of course. And he said, oh, you're ready, and we got to talking, and he told me about the advice that he heard quite some time ago, and there's a whole backstory to the advice that I won't drag through, but he said there were 4 key elements. When you're trying to reach an audience, right? The first one is that you have to be prepared. You have to know what you're talking about. So he said, are you prepared? And I was like, and he said, Karen, you're prepared. You're talking about your life's work here. There was literally no one in this room who's more prepared on this topic than you are. I said, all right, that's good. And he said, you have to be interested. That gets back to the thing that I mentioned a minute ago. You have to connect, you have to understand what the people in your audience, whether it's an audience of 1 or 2 on the hill or an audience in the room, you gotta connect with what they care about. And link what you want to say to what they care about. You have to be comfortable, because there's nothing worse to do to your audience than be uncomfortable. Because if you're uncomfortable, everybody in the room is uncomfortable, it's a miserable experience, just don't do it. And the 4th thing he said was, you gotta be committed. You gotta be always committed to what you're saying. And I was thinking the corollary of that, the flip side is, don't accept an invitation to speak on something you're not committed to. Right? So that conversation goes that way, and then all of a sudden, ding, 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 everybody sits down and it's time. And I have not had time to finish stuffing dazzling facts into my brain. So I just got up on stage and I gave the talk, and but that conversation with Bill put me into this entirely different headspace. It was no longer about impressing the audience. It was about connecting with the audience. It was about making what I had to offer meaningful to them and a good use of their time. And I think it went well. But that's not the end of the story. My favorite part of the story is that the next morning I was rushing out of the hotel to go catch a plane, and there's Bill sitting in the little continental breakfast area or whatever that little hotel was. And he's in a suit, he's reading his paper, drinking his coffee, and I went over and I said, Bill, I can't thank you enough for your advice. It just put me in a different headspace, made me think entirely differently about how I'm connecting and communicating, and I will never forget it. I said, except I've got a problem. I can only remember, you told me 4 things, and I can only remember 3 of the things. I feel like I have the keys to the kingdom, but they're slipping through my fingers here. And much to my great comfort, Bill said, oh, same thing happened to me. I could always remember 3 of the 4, but I could never remember all 4 at the same time. And then he said, but the key is, after thinking about this, I realized there's actually only one thing. You have to be committed. And if you're committed, you're gonna be prepared because it's something you care about. You're gonna be interesting because you will have thought about it from all angles. You're gonna be comfortable because you're talking about something you're committed to. So that's it, that's the one thing. So that's my answer. When you're talking to stakeholders on the Hill, when you're talking to your neighbors, when you're talking to people in other disciplines, when you're talking across public versus private lines. That's the key. That's all I got. I stole it from Bill. There you go. Oh, and I've got some NASA swag if you want it.